introduce Alon, who is visiting for a few months here at the Water Resources Research Center from Israel as part of a sabbatical. And Alon is a senior scientist at Israel's Oceanographic and Limnological Research Center. His expertise includes physical monitoring and a systems approach to hydrological and limnological modeling. And he does a lot of work on lakes, and particularly the Sea of Galilee, also known as the Kinneret. He's a consultant to the Israeli Water Authority, the Society for the Protection of Nature of Israel, and the Israeli National Park Authority, and to many environmental engineering companies. And he's published over 60 articles in peer-reviewed literature and chapters in edited books. And I had a chance to meet Alon last October. We knew he was coming to the States by then, but and then when I was in Israel to speak at a Jordan River conference, and we spent an afternoon together during which time I learned a lot. So Alon, as you've attended a few of our seminars, and you know we have some people attending via the webinar, but we do like to do introductions just around the room because our audience always changes. For those everybody doesn't know me, I'm Sharon Medgall, Director of the Water Resources Research Center. And we'll start with you and go around.
Mark Losleben with Soil, Water, and Environmental Sciences.
My name is Training. I'm from school on Lake Resort. Anyone?
Okay, great.
My name is Beth.
I'm with Water Resources Research Center.
They feel very interested.
Lori Richards.
Dick Elke, nobody.
Interested citizen. Ken Hollis, retired meteorologist. All right, and so we usually go for about 45 minutes or so, and then time for questions. And I think you know the routine.
I hope so. Okay. This is the salinity in the Lake Kinneret is an old subject. I will try to go over a few aspects of this salinity, not necessarily my work, but many other, some kind of introduction to the whole thing. And I hope within these few minutes that I have, I will be able to show you also some of the things that I did. This is my institute, Israel Oceanographic and Limnological Research. This is the north of Lake Kinneret. This is the Mount of Beatitudes and the church and some something that I bought from the internet.
So that is not your office building.
No. But we probably move here soon. And one more thing that I wanted to show you is about Lake Kinneret salinity in peer-reviewed journal. Not a joke, it's a real journal, Journal of Paleolimnology. Is there a paleolimnology explanation for walking on water in the Sea of Galilee? Okay. These guys that you see here, they are not, they are very well known. I mean, it's not a joke, this article. But you can, if you look at it, you can decide for yourself if you believe them or not. I don't know. I will not express my ideas about it. So you can see. You can see that the salinity is attracting many attention for many reasons. Lake Kinneret, the Sea of Galilee, is the most important surface water resource in Israel. It provides approximately 35% of the annual drinking water in Israel. The area is 2,730 square kilometers, which is part of it is in Israel, and the other part is in Syria and Lebanon. The average annual available water is 470 million cubic meters. I made a translation here. 1 cubic meter is acre feet, and basically it's about 0.25, which means a quarter of the cup supply each year. So just that you will know what we are talking about, this is the amount that can be extracted from the lake each year for supply, and you can see that it's about 0.25 of what the canal is bringing each year. So this is probably the right way to explain how it works. Lake Kinneret is used for water supply. I will show you in a minute, through what is called the national water carrier, for fishing, for recreation and tourist attraction. This is the east side of the lake. Some area connected to the Christian beliefs, and also boats for tourists. Something that is connected to what I saw in another lecture about how people are familiar with the lake level or with the groundwater level. I think you said something about New Mexico.
San Antonio,
Albuquerque.
San Antonio, and maybe Albuquerque, San Antonio,
Okay,
Texas.
so Lake Kinneret level is considered as the national level, national mood level of the Israelis. So when Lake Kinneret is high, everybody is happy because there is a lot of water. When Lake Kinneret is low, everybody thinks, oh, this is the end of the country, we don't know how to handle ourselves, and that's the problem. So this is a statue. It's about 2-3 meters high on the shore of Lake Kinneret in Tiberias. And just to show you how sensitive this thing, look at this picture, and you see that compared to this picture, there is something missing. This is the logo of the Israeli Water Authority. And when they built the city of Tiberias built it, they forgot to put the Water Authority logo here. So they immediately brought the artist, and he put the logo here. But this is an old picture from the time that this statue was built. Here you can see the level of the lake every minute. Every day, actually. So just to show you how important it is, okay, this is what was missing. This. Okay, the natural water sources of Israel, the Sea, the Galilee, and the Lake Kinneret provide 600 million cubic meters. It's not the 450 that I talked about, but it's 150 more because there is more supply to the region here, not directly from the Lake Kinneret. So this is about 600, the entire watershed bring about 600 million cubic meters, and these are aquifers in the rest of the area of Israel, the mountain aquifer, the Carmel aquifer, the coastal aquifer, and so on and so on. The canal built here started to work in '64, and this is carrying water from Lake Kinneret down south. On the way there are wells pouring water inside, so it's not the water of the lake only. It's water from the lake at the beginning, but then additional wells contribute more and more water to the rest of the area.
But the canal is at a higher elevation than the lake.
Yeah, I'll show you it in a minute. It pumps the lake very high, the water of the lake very high. So this is a basic picture Lake Kinneret and how it is connected to the rest of the Israeli area. So this is a bigger picture. This is the lake, and this is the national water carrier. This is where it goes. And this is the saline water carrier, which I will talk about in a few minutes. So this is a NWC canal, and this is the Sapir site where the water is pumped from the lake up to the mountains, and then the water flow to the south of the country. Now, as you said, the pump are taking the water from minus 210 meters to something like 150 meters, about 300 meters, very large pumps, and then it starts to flow, and then there is another pump that flow and take the water down to the south. Now, inflow of saline springs into Lake Kinneret. The salinity of Lake Kinneret, here we start our subject, is about 190 to 300 ppm Cl, and it's significantly higher than the salinity of the water from the surface streams. We have a lake, which is saline. All the streams that flow into it are freshwater. Their salinity is much smaller than that. And the relatively high salinity of the lake is a result of activity of saline springs located near the shoreline and offshore springs at the bottom of the lake. The salinity of Lake Kinneret considered as a major environmental problem, and reducing it is of high interest. I will explain it in a minute. So you see there are many places here where saline water goes into the lake. Sometimes they emerge outside to the air, and sometimes they emerge right into the bottom of the lake, and therefore very difficult to control and very difficult to monitor also. And I will try to elaborate later. Just to make a summary of the amount, so the annual water inflow of the groundwater is about 71 million cubic meters. This is just groundwater that flow into the lake. And the groundwater brings with it about 91,000 tons of chloride. So it's a large amount, huge amount of chloride. It salinized the entire lake. And therefore, at the end, we have, instead of having a lake with 30 or 40 milligrams chlor per liter, we have a lake with 240. This is the salinity. So the history of Lake Kinneret salinity, I will go through it very briefly, and we will come back to it after that. At the beginning, before the pump began, before this year, 64, there was an increase in the salinity. It reached something like 400. And then here it started to reduce because of the what is called the saline water carrier. And I will explain about it in a minute. Saline water carrier divert the saline springs from the few springs in the west, and therefore it reduced the amount of solute that go into the lake. And this procedure went until the 80s, and now it starts to a little bit climb again. And I will elaborate it later in my talk, but I just wanted you to have a first impression.
Question, was that increase before 1960 natural?
That's the great question, because I will return to it at the end of my talk, because it's a very important, I hope I will make it through the time that I have, but this is a very important question. And you will see during the lecture what I mean. So if we look at the national water carrier and we just look at the chloride that flow exported from the Lake Kinneret to the shore, to the other parts of Israel, we reached the amount of 775,000 chloride tons of chloride. I think it should be here, tons. Okay. So this is a large amount, 75,000 tons of chloride every year that leave the lake and go to the other parts of Israel. So annual chloride export is 330 million. Okay, assuming that. Okay, this is the amount. It's 75,900 kilograms of chloride each year on the average. And if you look at the salinity, we are now looking at this part of the country, which is the aquifer, the coastal aquifer of Israel. We see that it's highly saline. It's about, there are points which are 400 and 600, and it's increasing all the time. The salinity increases all the time. Part of the increased salinity is because it is irrigated by the products, by the water that comes from Lake Kinneret. So, Cl concentration in the coastal aquifer, the Cl concentration in the coastal aquifer is 50 to 600 milligram chloride per liter. The salinity increase annually with 1 milligram per liter. The irrigation with the relatively high Lake Kinneret water and the strong evaporation process in the region adds significantly to the salinization process here. Irrigation with treated wastewater add another source of salinity, and therefore we are trying all the time to reduce the salinity of the source water, which are Lake Kinneret, and so on and so on. So please note that the more saline areas are in the east of the aquifer, which is far from the sea. So the salinity here is not from the sea, it's from the irrigation. And this is a chloride concentration changes in the coastal aquifer 1950 to 2008. You can see that it keeps moving up all the time.
Oh, just a question. In that eastern part of the aquifer where it's highly saline, just out of curiosity, I don't think so. What's the depth to water in that area? How low below land surface is?
It can be 20 meters. 10 meters, 20 meters.
Okay.
It's not,
not
the
very
ground.
deep.
The groundwater here is not deep. It's about few meters. Now the shape of the aquifer is about 100 meters. The thickness is about 100 meters here, and here about 20 meters. So it's kind of a shape like that. Mm-hmm. And here, because of the irrigation, and there was work done on it, and showed that if you apply to a shape like this aquifer, you apply constantly solute, then the east side is more saline than the west side. So it was shown also with models. Now we return to the Lake Kinneret for a short explanation. What is the source of the solutes? Why there are saline water coming into the Lake Kinneret? And there are its geological findings, and this is not exactly my profession. And basically, there was, let's say, 20,000 years ago, there was a lake here called Lake Lisan, which was higher than the lake than the lake now. It was about 30 meters higher. And while it was there, and here you can see the lake was here, and it contributed salinity to the ground below. It contributed a large amount of salinity to the ground below, And when it disappeared this lake retreated, and therefore this became a river of fresh water, but it's still a river of fresh water lying, not the river, the lake is lying on saline soil. Okay? The entire area here, the entire lake, is actually lying on saline basis. And this is not a kilometer depth. It's 20-meter depth below the lake, and it's all saline. I mean, everywhere you go to the lake and you put your measurements, and you go not to the lake itself, but to the bottom of the lake, and you put your measurements 20 meters below, you will find very high salinity, 10,000 milligrams per liter of chloride. So it's actually a lake, which is freshwater lake, lying on top of saline water. Now, this entire saline sources, the salinity of the lake originates from springs that comes from here, and some part of it also from here, which all the time flush the salinity into the lake. Okay, so we have a kind of steady state. I don't know if it's a steady state exactly, but it's a kind of steady state, which says that every year we have fresh water on top running into the lake, flushing salinity from the bottom and bring it up into the lake. So this is the system. Now the last figures that I show you came from Hurwitz, Stanislavski, Wirtzman, and so on, which did a very interesting research during the 90s and the 2000s. Okay, now let's look at it let's look at the salinity mechanism from the side. These are the eastern Galilee mountains. This is Lake Kinneret, okay? This is about 1,000 meters, and this is about 12 kilometers. All this area here is filled with what is called the Kinneret brine. All this area here below the lake is the Kinneret brine, which are the remains of the old seas that were here many years ago. Here is the recharge area of the aquifers. The aquifers, the water flow down here. If you dig here, you find fresh water. If you dig here, fresh water. If you dig here, it's already saline. Okay? So here it's 40 milligrams per liter, here it's 600, and here it's 10,000.
So in that sketch, we would be looking to the north.
Yeah, this is when you look at the north and you look at the cross section from the west.
Mediterranean is to the left.
Yes,
Yeah.
exactly. Now, take a look at the SPM and the GFM. These are two mechanisms which were proposed to explain the relations between Lake Kinneret salinity and management. And I will talk about it in a minute. Okay, this is the SPM, and this is the GFM. So you have water here. They reach this area, which is impermeable layers, because it's layers that were collected during thousands of years, and when they reach here, they go up into the springs and come up as saline water. Now, if you look from the top, the green areas are basically the recharge area. This is valleys. They are less permeable. So the water that comes here actually goes below and emerge into Lake Kinneret in these springs here. Okay, practices to reduce Lake Kinneret salinity. One option is to capture the most saline springs in the west side of the lake and divert it around the lake to the lower Jordan River, the saline water carrier. This is the saline water carrier. I will show you in a minute. So this is an option which was started at 64 and was very successful. Other option is to pump the saline water near the lake directly from the aquifer and direct it to the saline water carrier. I will try to explain it in a minute. And number 3 is study the mechanism of salinization and decide on water management rules that will minimize the salinization. This is generally, we want to study how the water comes in, and if we understand it better, we might find a way to reduce the salinity of the lake. So this is the first thing that I mentioned. This is the capture the most saline. So 1964, there was a canal built here. You can see it. Now it's not a canal, it's a pipe, but this is from the time it was a canal. And it goes from the springs here along the west of the lake, and it collects saline springs from here and saline springs from here, and it collects it into this canal and pour it into the lower Jordan, where the lower Jordan is flowing into the Dead Sea. So this was operated in 1964, and I will show you in a minute how it affected the salinity. I showed you already, but I'll show you again how it affected the salinity. So this is the road, and this is the SWC. Pump the saline water directly to the SWC. This is an approach which was tried to put wells near the lake and to pump the brine directly from the groundwater, and therefore and take this water away. Now, if you believe that this is a final amount of solute, then it might be efficient, but I think this is, for our purposes, it's infinite amount of solute. So actually what you do, when you do this practice, you kind of take the solute from the depth of 1,000 meters and bring it up. And you did nothing, actually. So this was tried, but it was not tried for a long time, and it was rejected. Nobody is trying to use it anymore. Now, to study the mechanism of salinization is probably the most interesting part of it, because for years there were two approaches which had absolutely different conclusion regarding the operation of Lake Kinneret and the area. One is the gravitational flow model, which is the GFM, which I showed you earlier, which says something like that. The salinization is because, let's say it like this, when we have dry winter, we have low runoff, and then we have low lake level, and then we have small dilution with saline discharge, and therefore Lake Kinneret salinity increase. Okay, it has nothing to do with lake level, it has nothing to do with pumping or whatever. It just says that the saline water coming from the aquifers, and when we have more water, we have more salinity more solutes come in, and when we have less water, we have less salinity comes from the springs. The other approach was called the self-potential model, which is SPM, and the approach said that if we lower the lake level, we might have small hydraulic pressure on the brine, and therefore the brine will go up with higher rate, and we will have more salinity. And if we look at these two models, so let's see, the self-potential model, the major argument is fresh groundwater levels in the Eastern Galilee make a counterbalance to the driving pressure and therefore should not be decreased. Consequently, pumping of groundwater from this area should be limited. Okay, if this is a counterbalance on a pressure from here, we shouldn't pump the water here because it prevents the salinity to go up. And the same with the lake, with the lake level. The lake level should not be reduced below a prescribed level because lowering it will cause more saline to go up. This was the SPM model. The GFM model was almost opposite. The flow of saline spring depends on 100-meter head difference between this area and this area. So there is about 100-meter difference. And therefore, 1 4-meter change of the lake level has negligible effect on this flow. And reduced hydraulic head in the deep aquifer in the Galilee will lead to reduction of the pressure applied on the deep saline reservoir, and therefore salt flux into the lake will decrease. Okay, if we pump here, we will be able to decrease the flow and therefore decrease the amount of solute that flow into the lake. So one model is suggesting don't pump here and keep the lake level steady. The other model is saying, funny, huh? Pump here as much as you can because then you prevent water with solute to go into the lake, and the lake level doesn't affect anything. Obviously, when you go to the decision makers with such two diverse opinions, and both of them are in peer-reviewed journals, and I can show you at the end, I will show you, both of them are in peer-reviewed journals. So they didn't know what to do actually, but they decided that the SPM is right, and it was dominating because the people the people with these theories were probably more convincing than the others at that time. So the SPM theory was dominating. Pumping of the groundwater from the Eastern Galilee area was limited by the Israeli Water Authority for 4 decades. 1960 to 2000, the Eastern Galilee was not supposed, nobody was supposed to pump water. The lake level should not be reduced below a prescribed red line. This was the original, what is called today the red line, which was posted on many years on minus 212 meter and later on minus 213 meter in order to prevent the flow of the salinity into the lake. Then in 1995 and 2000 till 2000, a series of studies during these years came up with an important understanding that the GFM mechanism controlled the discharge of the saline springs. These findings resulted in the decision to lower the red line during the crisis of 1990 and 2000 without the fear of enhanced saturation. So basically, this was one of the most important findings, that we could show very clearly that this is monthly values, and this is monthly chloride recharge in ton into the lake, and this is the lake level. And we could show it very clearly that when the lake level is high, there is more recharge of salinity into the lake, which is opposite to the self-potential model. And why it is like that? Because it supports the GFM, which means that when you have a lot of water in the area, a lot of rain, then you have a lot of flush of groundwater, and a lot of groundwater will bring a lot of salinity. So this is one of the major findings, and that actually this model is better than the other model. And therefore, and in the talk about a few days ago in the tour, they were talking about the level of the lake, which is the meaning of the crisis. So I told you, you can use the Israeli system when you have a crisis, just lower the line.
We were talking about lake mead levels, yeah.
Yeah. So that's what they do in Israel. When there was almost a crisis here, they lower it to minus 213. And when there was almost it's a low, it's an Israeli low. The water authority cannot decide upon it itself. They need a law in the parliament or the government or whatever. And this was lowered, the line was lowered when it was obvious that Israel needs water. And there was a real crisis, but when they did it here, they already had all our opinion that there is no connection between lake level and the salinity. And we said it before it happened, not after. Really. And then they lowered and nothing happened. So you see that the idea, the science sometimes comes before the decisions, not after them.
The line is the water in the canal.
This is the level, the water level.
Water level.
Yeah, water level is going up and down yearly, every year. In the summer, and this is the summer and this is the winter. Sometimes when there is a very, very powerful winter, you have an increase like that or increase like that. And but today it's mainly 1.5 meters a year or a little bit less.
Up and down.
Yeah, and the way down is the way down without the pumping was supposed to be 1 meter, 1.5 meter. When you see more than 1.5 meters, then it means we are pumping. So all this, for example, is because of pumping. It's not because of there was no water or whatever. It was because the amount of water that was getting in was less than the amount of water that was pumped out. Okay, let's look at the history of the salinity again. Lake salinity model.
So by the way, did you miss number 2 on those 3 options, or did I miss something?
Number
When
2.
you had the slides and you had the
Yeah.
slide with
The number
strategy.
2 was to take the salt directly from the
I
soil,
thought that was from the soil.
not from the soil, from the aquifer.
Okay,
It
right.
was here.
That's.
You talked about it briefly.
Yeah, no, you went back too far. Yeah,
This you mean?
yeah. So both 1 and 2 are SWC. Okay, Okay,
Yeah.
I missed that those were
But this
both
was
SWC.
a suggestion because we couldn't find
Yeah,
more.
okay, so that was where you
Okay.
took it off.
Yeah.
Okay.
So let's look now at lake salinity model. Lake salinity model is something that I developed in order to look at the long-term prediction, what's happening to the lake salinity. And the structure is very simple. You actually take the chloride from the water inflows from the surface sources, which are kind of fresh, and these are saline. You put them together and you say, okay, let's put the amount of annual solute inflow into the lake. And then we mix everything together, the amount of water and solute that was there with the incoming, and then we pump out from pumps, and you put everything in equations, and you have a model of lake salinity. It sounds simple, and it's also simple. It's not very complicated. Now, if you look at the results of this model, and the input to the model is that you put S in at that level, and all of a sudden in one certain year, you reduce the S in, the amount of solutes into the lake, you reduce it from here to here, and it starts to be less. This is called step function. It's a step function. S in is a step function which starts here. And then you look at the lake, amount of solute in the lake. The model shows that the amount of solute in the lake will reduce exponentially, and it will take about 25 years for this certain system to go from this steady state to a new steady state. So this is what happens if a sudden drop in solute inflows, operation of the SWC will cause an exponential decrease of solute mass and salinity. And this is exactly what happened during the operation of the SWC. The SWC started to work in 64. Before that, we had this amount of solutes coming in, and after that, we had this amount of solutes coming in. And if you make it kind of model like that, you get this result, which is the exponential decrease of the lake salinity from 64 to 87. And this is exactly what happened, and it's a model which doesn't need any calibration. It's all built on data. And it really, I didn't bother to calibrate it. It just worked like that. This is because of 1969, which was very high rainfall. So it takes the results a little bit down, but basically this is what happens. So this is the model showing what happens if you cut the solutes inflow into the lake. In 1 year, you all of a sudden cut it in a step function. So this is the SWC in 64. Now let's look at another phenomena, schematic lake salinity response to gradual changes in water inflow. Let's assume that the water that comes into the lake are not remaining the same amount all the time, but we have less and less water during the year, okay? We start from 60 or whatever, now we are 2010, and the water inflow into the lake, the entire amount of water inflow into the lake from the Jordan River and from the other streams and from groundwater, everything is decreasing linearly. Then the model shows that gradual decrease in water inflows will cause a non-linear increase of solute mass and salinity. This is the result of water inflow reduction. Now again, why I show it? Because this is the amount of inflows to the lake during the years. At the 50s, it was 600. million cubic meters, and now it's 450. And if I assume that it's linear, okay, it's not linear obviously, but I assume that it's a kind of behavior which is typical, which is linear. This is what I get. And this was very important finding. From 1964 till the 80s, the Lake Kinneret salinity reduced like that. Now, what was the reason? It was because of the saline water carrier, which was operated starting here. When it started to operate, then we took away some of the solutes, and the lake salinity reduced. Now, during all these years, there was also an increase in the salinity because of the reduced amount of water that comes into the lake. But we couldn't see it because this was very large and the amount of increase was very small, so we couldn't see it. When do we start to see it? When this reaches a steady state. Only when it reaches a steady state, then we can see the increase of the salinity. So throughout all this time, we couldn't see that the lake is actually getting more and more saline. Only at the 80s, we started to see it. And when I showed this graph to the water authority, I remember one guy at the audience said it wouldn't happen. It was 8 years ago, and I said, look, what's happening? You are taking water at the Upper Galilee, you are increasing the amount of water that you take in the Upper Galilee, and if you take water from the Upper Galilee, you reduce the amount of water that comes into the lake, and then you make the lake more saline. At the same time, you say, but we want to reduce the salinity of Lake Kinneret. I told them, look, it doesn't work together. You either take water from the North Galilee, or you want to reduce the amount of salinity in Lake Kinneret. It doesn't go together. If you reduce the amount of water that goes into the lake, the salinity will go up. That's what the model shows, and that's what the data show. It was 2007. Now we are in 2015. About half a year ago, just before I came here, I started to hear from the water authority that this opinion started they started to talk about it. I mean, 7 years it took them to digest the fact that we are not in a steady state, but we are in a state that the Kinneret is getting more and more saline. Okay. I have one more thing. So the prediction is that if we go on and pump water from the Upper Galilee, the Lake Kinneret salinity will increase. This is the prediction. Now, regarding your question, the historic record of lake salinity during 50s to 64. This was an increase in salinity. And remember that at this time, nobody knew about what will happen here because it wasn't. So they had only this data. They saw that the Lake Kinneret salinity increased. Why Lake Kinneret salinity increased during the 50s? How it is connected to the LSM theory, to the lake salinity model theory that I just showed, and how it is connected to the red line policy. That's what I will try in 5 minutes. Why Lake Kinneret salinity increased during the 1950s? Various academic references noted that the 50s and the beginning of the 60s were relatively dry, and therefore relatively little fresh water reached the lake and caused increased salinization. Okay, we see these years. The red shows dry years. During these years particularly, which were dry, the lake salinity increases. So these dry years are known because they were measurements. But then I want to ask a question, is this a complete explanation? And that's what I found. The calculation from October 1954 to October 1962 suggests additional solute inflows during this period. Okay? It's not only that it was dry and there were less water flowing into the lake, there was an additional solute inflow during this period. From solute balance calculations, it is possible that during this 8-year period, the input of solutes to the lake increased to an annual average of 168 instead of about 8,000 tons larger than what we know in the years that followed. Okay? We all of a sudden during these years, when you look at the balances, you see that there is an additional amount of solutes at this year. How come? It was dry years. Dry years bring less solutes. How come in these years there was more solute? And then I looked at the database of the Israeli Hydrological Service, and what I found was that during the 1950s, the state of Israel carried out an intensive research on the Lake Kinneret salinity in preparation to develop the operation of the NWC. As part of this research effort, at least 60 new boreholes, which is from the IHS database, the Israeli Hydrological, were drilled in the region of the west coast of the lake, from which at least 28 boreholes were drilled offshore in the bottom of the lake. Okay? All these were drilled at this period, 1950, 1960. And you can see it here. This is the shore. These are the boreholes. Take a look at this number. It's written 1958. This is about the years it was drilled. This is in Tabcha. This is in Fulya, 1958. And this is in Tiberias, 1958. All these holes were drilled during the 50s and the 60s. So imagine that you have here drills that goes from the saline water to the lake. Now imagine that you can control it and you can operate it and everything is fine, but you have errors, you have problems. Sometimes the well is flowing out without control. Then what you do is you take saline water and you add it to the lake. And you did it yourself. Nobody helped you to do it. Summary.
Not what they wanted to hear.
Yeah, and by the way, when I tried to look at this phenomena, and I did it several years ago, nobody answered me. Nobody. I couldn't get any from, I went to people which at that time were 80 years old, and I asked them about it. Nobody, they didn't say no, they just didn't answer. And there is a guy in the Israeli Hydrological Service, which is now 75 years old, and he remembers that it was kind of known, but nobody talked about it at that time. So, since the operation of the national water by the way, I didn't mention it, but because of that, because of this increase, it is well known in Israel, extremely well known, that if the lake level drops, we will have an enormous problem of salinity. It's well known. And you can go from lecture to lecture and tell them, forget it, it's not true. You can lower the level, although you don't have to lower it, but you can lower the level, nothing will happen to the salinity. It doesn't help. It's the entire generation, really entire generation from the 60s to the 40 years, they all know that when you reduce lake level, when you reduce the lake, there will be an enormous amount of salinity problem. And it's very difficult to change this.
Well, it's the, go back to that one just before.
This
Yeah.
one?
Yeah, before 50, before these boreholes and
Yeah.
so forth. It presumably was reasonably steady over
Yeah.
time,
We assume that it was about 300.
the time immemorial.
Ah?
Till way back.
Yeah.
Whatever.
Yeah, we assume that for many years, like decades, it was about 300. Probably went up and down according to years, which were. Okay, so let me just. Since the operation of the national water carrier in 1964, the Lake Kinneret salinity causes major environment problem. The following two aspects were discussed: description of the case study, the lake salinity as a source of solute. 2, the hydrological causes. 3, history. Management of operation. The proposed mechanism of lake salinization and the determination of the red line policy to ensure minimum allowed lake level, a complete mixing type model, and summary. Okay. Is there a justification for the red line policy from the salinization point of view? And I think that from the salinization point of view, the red line policy doesn't count anymore. There is red line to the lake level, but it's not connected to the salinity. It's connected to the operation of the lake, it's connected to the biology, it's connected to the tourism activity. It doesn't have a real effect from the salinity point of view. That's it. Thank you.
Well, thank you very much. Good question.
Yeah.
What has been the impact of sending all that saline water south down the saline water carrier? Like, where does it go to create problems further south?
Yeah, the saline water carrier, there are differences. Since it is very important part of the Jordan River now, the lower Jordan River, nobody wanted to take it away because they said if there is flow, at least there will be some flow, otherwise there will be dry. And therefore, when there was, during the last years, it was suggested to take this saline water and to create with them, to direct them to the south and make fish industry. It wasn't not many people supported it. Now, the